Good evening, friends. Today we are going to discuss about the questions frequently asked in GATE. Let us start with matrices. Given. Okay, I will make my pen smaller. Given matrix A. Okay, given matrix A, it is 4, 2, 1, 3, and it is 6, 3, 4, 7, 2, 1, 0, 1. Okay, find rank. Find rank. So finding the rank, finding the solution of system of equations, finding the eigenvalues. These are the main area of concentration. Okay, so here when you see the first determinant is this one, determinant 4, 2, 1 and 6, 3, 4, 2, 1, 0. 2, 1, 0, we expand the determinant along the last column, 1 into 6, which is equal to 1 into 6 minus 6, that is 0, minus 4 into this one, 4 minus 4, 4 minus 4, and plus 0 into. So this gives you 0. So this is equal to 0. So this determinant becomes 0. Okay. Similarly, this determinant 2, 1, 3, 3, 1, 3, 4, 7, and 1, 0, 1. This determinant also becomes 0. 4. 2 into 4 minus 1 into 3 plus 7, 3 minus 7, that is 4, and 3 into 0 minus 4, 12, it gives 0. And these all 3 by 3 minus becomes 0. All 3 by 3 minors becomes 0. Minors become 0. So we have to check for any 2 by 2. Any 2 by 2. Okay, any 2 by 2. Any 2 by 2. 2 cross 2 matrix. Like for example, this one 6 minus 6, 0. 4 minus 0. So this one not equal to 0. Okay. You can take anything 4, 2, 6, 3. Okay. So this is 12 minus 12. See the last minor of order 2. 4, 7, 0, 1. Right. So this is 4, which is not equal to 0. So the rank is 2. So rank is 2. So this will be the answer. Okay. So we have to find the determinant value. Otherwise, you have to reduce the row by row column. You multiply this by 4, you reduce, multiply this by 4, you reduce, and you can find. These two techniques are available, but getting the determinant is a good technique. Another one I asked in 2003 for a matrix 4114. 4114. What is the eigenvalue? What are there are two eigenvalues here. What is the main formula for eigenvalues? It is a minus lambda is equal to 0 is equal to 0. That is a shortcut. Lambda square, sum of the roots minus 8 lambda plus 16 minus 1, 15. 16 minus 1, 15. Okay, is equal to 0. You factorize this. This is lambda square minus 3 lambda minus 5 lambda plus 15 is equal to 0. And then we have lambda minus 3 minus 5 lambda minus 3. Quickly we can factorize. Okay, and lambda is equal to 3 comma 5. You are not expected to do until the n. you are going to find the values. Lambda is equal to 3 comma 5. This is another question. Question number 1 and question number 2 with respect to the matrix. Question number 3, we have the following simultaneous equation: x plus 2y plus z is equal to 6, z is equal to 6, 2x plus y plus 2z is equal to 6, 2z is equal to 6, x plus y plus z, x plus y plus z is equal to 5. And you are asked about the unique solution. Unique solution, maybe no solution, infinite number of solution, exactly 2 solution, likewise exactly 2 solution. The point is you have to solve this. Matrix. You have to solve the augmented matrix. You write in the form of Ax equal to B, right? You are not expected to do all these things in the rough work. You roughly you put 1 2 1 6 2 1 2 6 and 1 1 1 5. Okay, 1 1 1 5. You do echelon form. You change the first row to third row. You subtract the first row. 1 minus 1 0, 2 minus 1 is 1, 1 minus 1 is 0, 6 minus 5 is 1. Okay, right? You have changed this one. Okay, second one, 2, here it is 2. You multiply by 2, 2 2 2 4 10, 2 1 2 6. You subtract 0 1 0 4. So 0 1 1 0 4, 0 1 0 4. Again you do the process. It is the first row is 1 1 1 5, second row is 0 1 0 1, and subtracting this gives you 0 0 0, and this one is 3. Okay, this one is 3, right? See, here we have a situation where this matrix has a rank 2, whether the system has 3 unknowns. Okay, so the rank of A is not equal to rank of A comma B. Not equal to rank of A comma B. So simply by doing the echelon row by row reduction, you say it has no solution. It has no solution. So this is the solution. We can do either way by getting the determinant, but that is a very long route. You can have a short route by doing the formation in a rank. Okay, right? So consider the following linear equation. Consider the following linear equation. You have 2 1 minus 4, 2 1 minus 4, 4 3 minus 12, 1 2 minus 8, 1 2 minus 8, and again it has x y and z, and here we have alpha 5 7, alpha 5 7. This is one type of question. Notice that in third and for second and third column, right, they are linearly independent. Okay, you take these two, right? You take these two out. You have for if you divide by 4, that is 1 3 2. So this third column and the second column are linearly independent. Okay, so for how many values of alpha? For how many values of alpha the system of equation has infinitely many solution. Infinitely many solution. So question is, for what value of alpha it has infinitely many solution. Okay, for this you write augmented from 2 1 minus 4 alpha 4 3 minus 12 5 and 1 2 minus 8 8, 7. You write like this in a augmented form, right? Infinite solution exists when the determinant becomes 0. When the determinant becomes 0. So when you have 1, 2, alpha, 4, 3, 5, you take that matrix 1, 2, 7, you find is equal to 0. You solve this. 2 into 21 minus 10, 10 minus 1 into, okay, so 1 into 28 minus 5 plus alpha into 8 minus 3. So 21 minus 10 is 11. 11 into 2 is 22. 22 minus 28 minus 5 is 23. Minus 23 plus alpha 5 alpha. 5 alpha equal to 0. Equal to 0, equal to 0. So 23 minus 1, it is minus 1. Alpha, 5 alpha is equal to 1. Alpha is equal to 1 by 5. Alpha is equal to 1 by 5, which is the alpha which has infinitely many solutions, right? So these are the types of solution type of problem where you have to work out. See, there is another problem where you have to really find difficult, right? So real matrix A is of order 3 cross 1. Real matrix A is of order 3 cross 1. The B is of order 3 cross 3. 3 cross 3. C is of order 3 cross 5. 3 cross 5, and D is of order 5 cross 3. 5 cross 3. E is of order 5 cross 5. E is of order 5 cross 5. E is of order 5 cross 5, and F is of order 5 cross 1. These are the orders of the matrix given. Okay, matrices B and E are symmetric. B and E are symmetric. Symmetric in the sense Aij is equal to Aji. You have to remember Aij is equal to Aji. The transpose is also equal. A is equal to A transpose. Okay. The following statement are made with respect to these matrix. Okay. Following statements. Matrix product F transpose, C transpose, B, C, B, C, F is a scalar. Is a scalar. Is a scalar. This is question number 1. Question number 1. There are two statements. This is statement number 1, and statement number 2. D transpose F D. D transpose F D. Always symmetric. Symmetric is always symmetric. Okay. F transpose. What is F transpose? 1 cross 5. What is C transpose? 3 cross 5 cross 3. 5 cross 3. Okay. So this is 1 cross 3. 1 cross 3. What is B? 3 cross 3. 3 cross 3. This is 1 cross 3. 1 cross 3. Okay. What is C? Again it is 3 cross 5. 3 cross 5. Again it is 1 cross 5. 1 cross 5. Okay. What is F? 5 cross 1. See, now the end product gives you 1 cross 1. So 1 cross 1, which is a scalar. So you can say this statement is true. Statement 1 is true. Statement 1 is true. Okay. TRUE. Okay. D transpose is 3 cross 5. F is 5 cross 1. So this is 3 cross 1. 3 cross 1. What is D? 5 cross 3. 5 cross 3. We cannot give a product. F cross D is also not allowed. So this is not allowed. So we can say that statement 2 is false. 2 on the false. Okay, 2 is false. Okay, so statement true, 1 is true, 2 is false is the correct answer. Okay, right? So there are some problems. There are some problems which are very interesting, right? A, B, C, D. A, B, C, D. A, B, C, D are all n cross n matrices. N cross n matrices. Okay, each with non-zero determinant not equal to 0. A, B, C, D. A, B, C, D is equal to identity. A, B, C, D is equal to identity. Then what is B inverse? B inverse. B inverse. What is B inverse? Okay, right? A, B, C, D. Okay. So first of all, we can say A, B, C, D, D inverse is equal to I into D inverse is equal to D inverse. Okay. Again A, B, C, C inverse. This becomes I. This becomes I. C inverse is equal to D inverse, D inverse, C inverse. Post multiply C inverse. Okay, now this becomes I. A, B is equal to D inverse, A inverse, AI is equal to A inverse, D inverse, C inverse. Pre-multiply. So B is equal to A inverse, D inverse, C inverse. Okay. So A inverse, B inverse, D inverse. Right? So that is a B inverse. A inverse, D inverse, and C inverse is B. Okay, that is B. So what is B inverse? A inverse, D inverse, C inverse, inverse, C inverse, inverse. This is okay. Then now we can write C inverse, inverse, D inverse, inverse, and A inverse, inverse. So that is B inverse. So what is B inverse? C D A. B inverse equal to C D A. So you should not stop here. This answer will also be given. This is not a correct answer. We want B inverse. Here it is I. So we have B only. So if A B inverse, we have a formula A B inverse. We have a formula B inverse A inverse, B inverse, A inverse. So that we are having this property, we are doing this process. Okay, right? Find the sum of the eigenvalues. This is another beautiful question. Sum of the eigenvalues of 1, 2, 3, and 1, 5, 1, 3, 1, 1. Sum of the eigenvalues. What is the sum of the eigenvalues? The sum of the eigenvalues is equal to the trace of the matrix. So 1 plus 5 plus 7. That is one property you have to remember. So sum of the eigenvalues is equal to, what is the product of eigenvalues? Product of eigenvalues is equal to the determinant value. Determinant value is the product of the eigenvalues. Likewise, you have to remember when alpha A1, A2, A3, alpha 1, alpha 2, alpha 3 are eigenvalues of a matrix A, then A inverse will be 1 by alpha 1, 1 by alpha 2, 1 by alpha 3. Okay, so in matrices we have different kind of set of questions. Mainly they are asking about system of equations, unique solution, infinite solution, many solution, and so on, no solution, and then small identities in this matrix regarding the inverse and other things, eigenvalues, eigenvectors, and small some orthogonal matrix also. What is an orthogonal matrix? A is an orthogonal matrix. A transpose equal to I. A transpose equal to I. The multiplication of the transpose matrix is also I. So whenever you are given provided with a matrix which is an orthogonal, you just multiply with the transpose, that gives you an answer. Okay, so these are the main types of questions asked with respect to the matrices. For a matrix 3 minus 2 2 0 minus 2 1 0 0 1, one of the eigenvalues. See, this is an beautiful question. We have discussed already. 3 minus 2 2 2 0 minus 2 1 minus 2 1 0 0 1 0 0 1. One eigenvalue is equal to minus 2. One eigenvalue is equal to minus 2. See, for a lower triangle matrix, upper triangle matrix for lower triangle 0, the eigenvalues are the diagonal values. So it is 3 minus 2 and 1. Other two values are 3 and 1. A very easy problem. It can be solved. So what are the eigenvalues? 3 minus 2, 1 are the other eigenvalues. Okay, so these are the questions mainly asked in the matrices with respect to the trace of the matrix, with respect to number of solutions. So when you are very particular, you can go for any notes you can take, you can answer these type, you can very well follow my lecture, so that you can get 100% mark in the matrices session, right? Mainly all the questions I have analyzed, all the questions so far, I have analyzed 12 to 13 question patterns. All are asked about linear dependence, linear independence, and so on. Okay, so these are the thing which is asked, and I shall share the video, so that you can have thing. Next class we can see the continuity and so on. Okay.